when we start doing 2 dimensions. Remember, I know it's been a couple of weeks. We've all had a couple of weeks. We've all had all kinds of craziness, but we talked about the fact that vectors have direction and magnitude. And we've used vectors all along. If I walk, if I walk 3 blocks this way, and then I walk 2 blocks this way, we get a, quote, resultant vector, or our distance vector that we get there. This is we've added this vector plus that vector to get this vector. And we know, since this happens to be this way, we know that this is going to be the square root of 2 squared plus 3 squared, which gives me the square root of 4 plus 9, which is going to give me the square root of 13. So the magnitude of this one would be the square root of 13. And then I can use my trigonometry to calculate the angle. The tangent of that angle is going to be the opposite, 2 divided by the adjacent. Did I do that right? No, yeah, opposite divided by adjacent. So my angle is going to equal the arctangent 2/3. And if I do that, that gives me my angle is equal to 33.7 degrees. And that's the kind of stuff we were doing at the very beginning of the semester. Well, let's talk about vectors. So I could rewrite this vector. So we've got our resultant vector. It has a magnitude. We're going to call the magnitude of r. It says it's going to be the square root of 13. Our angle here is going to be 33.7 degrees. But I can write this r as 3 in the I direction plus 2 in the y direction. This is what we call a vector notation. Now, some of you may have seen it like this. This is also a vector notation. But what I is considered a unit vector in the x direction. And j is a unit vector in the y direction. And I'm going to add it here, and then I can go and I can do my magnitude and everything else. So we can take vectors and we can break them into their components, or we can take their components and draw them up into going back and forth. Well, that's going to become very important when we're going into 2 dimensions, because we've already seen that if I drop a ball, this motion is independent of this motion. So my x and y motions are independent. And you might remember seeing that from the basketball. So my basketball did this. So this was the path that the basketball did, right? Person was standing over here and it went over there. That was my path that was traveled. But when we did the graphs, I got one graph that looked like this, and I had one graph that looked like this. This was my x direction. and this was my y direction. This one had acceleration. This one, the acceleration was equal to 0. The motion in those two directions were different. So we can do some things. So if I have a vector, and we're going to call this vector A, and we're going to give it this, and we're going to go ahead and say it's equal to x in the I direction plus y in the j direction. If I do a scalar, and this is a scalar, it's just a number, and I do 3a, that means that this is going to equal 3x plus 3y. So I can do my math on my scalar. If I do a -1 in front of my vector, this is going to be a negative x, and this is going to be a negative y. Okay? So I can take my scalars here. So if I do that, if I take vector A, and this is going to be 3 in the I direction minus 4 in the j direction, and I take vector B, and this is going to be, we're going to make this -1 in the I direction plus 3 in the j direction. I'm going to do it graphically. So I'm going to start out with vector A, and I'm going to use my dots here on my paper. My vector A is 3. 1, 2, 3. So my vector A is 3. And it was -4. 1, 2, 3, 4. So here's my vector A. Okay. That's what vector A looks like. But vector B, we're going to add it head to tail. So it says it went -1, but it went +3. 1, 2, there's 1, 2, 3. So I'm -1 and 3. So my new vector, I'm going to use my black, is up here. So that's my vector B. And my resultant vector, got green, I got blue. My resultant vector is going to be my blue vector. There's my resultant vector. This would be R. So if I do it here, R would be 2 and 1, because that's how I did it on my graph. Well, guess what? A plus B, I'm going to add up my items in the X column, and I'm going to add up my items in the Y, and I get 2I minus 1j. And that's exactly what we got graphically. So I can add these vectors graphically. If I were to do A minus B, okay, well, first of all, minus B is equal to 1 minus 1 times my B vector. So that is going to mean that now I get 1 in the I direction minus 3 in the j direction. That's equal to minus B. So now if I take my A vector, which was 3I minus 4j, now I'm going to get 4I minus 7j is my A minus B vector. If I want to know the magnitude of this vector, that is going to be the square root of 4 squared plus minus 7 squared. That's going to be the square root of 16 plus 49, which is going to equal the square root of 65, I think. Yep, that equals the square root of 65, and you can actually Go ahead and take it out and calculate the square root of 65. And that's going to equal 8.06. And I can also calculate the angle. The angle is going to be the arctangent of my -7 over my 4. And it says I'm going to get a negative 60 degrees, 0.3. But if I'm drawing this vector, so you can verify your angle, right? My vector for this one, I'm going to be over 4, which we're going to start from here. 1, 2, 3, 1, 2, 3, 4, and we're down 7. 1, 2, 3, 4, 5, 6, 7. This is our negative 60.3 degrees. Okay, so what we've done is we've reviewed our one dimensions vectors, our one-dimensional motion, and then we've reviewed our vectors for tonight. Any questions about the vectors?